In this video, we need to go back to value types. So types are one of the fundamental aspects in programming, and converting between types is something that we do in every programming language. For example, converting a string to a number or a number into a Boolean is something that we do all the time. And so it's important that we learn about this before being able to move on further in the course. That's especially true for a language like JavaScript, which sometimes behaves in a weird way, as we will see in this video. Now, in JavaScript, there is type conversion and type coercion. So they sound very similar, but are different. So type conversion is when we manually convert from one type to another. On the other hand, type coercion is when JavaScript automatically converts types behind the scenes for us. So that's necessary in some situation, but it happens implicitly, completely hidden from us. Okay, so let's start with type conversion, which, remember, is when we explicitly want to convert from one type to another. So let's say that we have an input field on a web page for the user to input their birth year. And these inputs from input fields usually come as strings. So let's say that the input year that we get from the user interface is a string with the value 1991. But now, if we want to do some calculations with this, this won't really work. So let me show that to you. So console.log, let's say input year, and now plus 18. And so like this, we can calculate in what year the person will become of full age. Now, remember that when we have a string and add something to the string, it will basically concatenate the strings. So we can't expect that this actually adds 18 to this number here, because it's a string. So let me show you what I mean with that. And so indeed, we now get a string, which basically contains the 1991 string and then the 18 as well. Okay, so we need a way of fixing this, which means that we need a way of converting this string to a number. So let me actually log that here first. So console.log. And then the way we convert this string to a number is by using the built-in number function. So we write number, then parentheses, and then input year. And we will learn exactly what a function is and why it works this way in the next section. For now, just know that we can basically convert strings to numbers by using this function, which we execute using these parentheses here. So we have these parentheses inside these parentheses now, but don't get confused by that. So doing this operation here will then return the string as a number. So let me show that to you. And so indeed, now we get 1991 here in this pink color, basically. And the colors might change throughout the time. By the time I record this video, numbers are pink and strings are just this white. Let me actually print them both. And so that should make it really visible that, yeah, the first one is a number, the second one is a string. Okay. But now, one thing that's really important to note here is that the original value is actually not converted. So the input year variable itself, so this one is still a string, right? It still holds the variable 1991 as a string and not as a number. That's why down here in this log, where we do this calculation, the result is still this string. Because again, the original input year variable is still a string. Using this number function will simply give to us a converted version. So if we want to perform this calculation, we need to use number here as well. And so this will now convert the number, and then to that number, the 18 will be added. And so now we should end up with something like 2009, I guess. And indeed, that's right. But now, what if we're trying to convert something to a number that is impossible to convert? Let's try that with a string that doesn't really contain a number. So let's try to console log converting to a number the string Jonas. So JavaScript will look at the string, will try to convert it to a number, but it won't really work. So what do we get instead? We get this nan, which stands for not a number. So JavaScript gives us this not a number value whenever an operation that involves numbers fails to produce a new number. So basically not a number actually means invalid number. It's not really not a number. And let me actually prove that to you. So we can check the type of NaN, so not a number. And as we will see, the weird result of this is that the type of not a number is actually number. And so again, not a number actually means an invalid number. It's still a number somehow, but it's an invalid one. And so again, we get not a number whenever an operation involving numbers fails to give us a new number. Okay, so that is converting strings to numbers, but of course we can also do the opposite. It's a little bit less important, I would say, but I still want to show it to you. So to do it the other way around, we use this string function, and that's quite straightforward, right? Just keep in mind that we need to really start it with a capital S, just like here the number function needs to start with a capital N. Otherwise, it's not going to work. So we get 23. And remember that whenever the value here is white, then it means it is a string. So it looks kind of the same. Let's again log both just to make this point. So the pink one is the value that actually has the number type, and this one has the string type. Okay, so again, this one is not as important, but I still wanted to mention it. Now, JavaScript can only convert to 3 types. So we can convert to a number, to a string, or to a Boolean. But we cannot, for example, convert something to undefined or to null. That doesn't make a lot of sense. Now here we only converted to numbers and to strings, but not to Booleans. And that's because Booleans behave in a special way. And for that reason, there is a separate lecture coming up on so-called truthy and falsy values. Great, so that is type conversion, where we do manually convert from one type to another. However, in practice, we rarely have to do it manually, because JavaScript actually does type coercion automatically for us in many situations. So let's talk about that now. And let's just separate this here with some comments. So type conversion, and then type coercion. So basically, type coercion happens whenever an operator is dealing with 2 values that have different types. So in that case, JavaScript will then, behind the scenes, convert one of the values to match the other value, so that in the end, the operation can be executed. And actually, we already saw that happening, if you think about this. So let me show that to you. Starting with strings, remember how we did this. I am, and then a number, let's say 23, and then another plus years old. So we already know that this is going to produce a string that says I am 23 years old. But how does that actually work? Because 23 is a number, so we have different types here, right? We have a string, a number, and another string. So let's check, and indeed that is what happens. And it works this way because of type coercion. So in JavaScript, the plus operator that we used here triggers a coercion to strings. And so whenever there is an operation between a string and a number, the number will be converted to a string. So thanks to type coercion, writing this would be exactly the same as writing this. Right? Because again, the plus operator will convert numbers to strings. And the same actually happens in template literals. it also takes all the number values and also converts them to strings. Now, if JavaScript did not have automatic type coercion, like many other languages don't, then we would have to manually do this like we just learned before. Then we would have to do string 23, and then this would be the only way that this would work. But luckily for us, JavaScript has type coercion, and so this will happen completely automatically behind the scenes. Now, actually, not all the operators do type coercion to string. So let me show you something else. So if we do 23 the string minus 10 the string minus 3, what do you think will happen now? So let's actually check. And it gives us 10. So what happened here? It looks like this time JavaScript converted the strings to numbers. And indeed, that's why we get 10. Because 23 minus 10 is 13, minus 3 is 10. And so what this means is that the minus operator actually triggers the opposite conversion. So in this case, strings are converted to numbers and not the other way around. So instead, if we use the plus, what do you think is going to happen? Then the 3 is converted to a string, and then the 3 strings are concatenated. Okay, so this is a very important distinction to keep in mind, because this actually confuses many JavaScript beginners when they don't know about this. So let's try another one here, and I'm again using 23 the string times 2 the string. And again, you will see that these values are going to be converted to numbers before. And indeed, that's why we get 46, because both of them are now converted to numbers, because that's the only way that the multiplier operator can work. And the same, of course, is true for dividing. Now, one final example is a logical operator. So let's check 23, the string, again, greater than 18, the string. So, do you think this is going to work? Yes, it does. So 23 the string is still greater than 18 the string, because once more, JavaScript will convert strings to numbers automatically. The only way in which it doesn't do that is the plus operator. In plus operator, again, it happens the other way around. All the numbers are converted to strings. Okay, I hope that distinction is now pretty clear. So just to make sure that you really got it, let's play a game called Guess the Output. So that's a game I just made up. So I want you to guess what happens here. So I'll write 1 plus 1 like this. And then we say n equals n minus 1 again. So what do you think n will look like when we log it to the console? So essentially we start with 1 the string, then we add 1, and then we subtract 1. So take a moment to think what this should look like, and then let's take a look at the solution. And it is 10. So that's a bit counterintuitive, but according to the rules that we just learned before, it actually makes sense. So here in the first line, 1 plus 1 will actually turn out to be 11 the string, because we have one string here, and then the plus operator will automatically convert the number to a string. And so the result of this one is the string 11. But then here we have the minus operator. And in the minus operator, whenever we have a string or more strings, it will then convert it to a number. And so here, the string 11 will be converted to 11 the number, and then 11 minus 1 is of course 10. Okay, let's do one or two more, and let's do it in the console here. And we can actually clear the console of all this clutter here by clicking on Clear Console. Okay, so let's do 2 plus 3 plus 4 plus 5 the string. And now you actually can't really guess, because we can already see the solution there. Okay, So let's try to understand what happened here. So we start here with 2 plus 3, which makes 5. Then 5 plus 4 makes 9. And then we end up with 9 plus 5, the string. And then, as you already know, since we have a string, the plus operator will convert the other operand, which is 9, also to a string. And then we end up with 9, 5 as a string. Okay, and another one. 10 minus 4 minus 3. And keep in mind that these are strings. And then minus the real number 2. But then plus 5, the string. So again, this looks very weird, but the logic is kind of the same as before. So we have two values that are subtracted, and so JavaScript will convert them both to numbers. And so the result of this is 6. Then 6 minus 3 is 3. Then 3 minus 2 is 1. And then we end up with the same situation as before. So this 1 will be converted to a string, and then we end up with a string 15. Okay, and with that, I think this should be pretty clear now. And you might be wondering why we're talking so much about this, but it's really important that you know about this right from the start so that you can write your code with all of this in mind. Now, many people actually don't like type coercion and think that it's a bad practice to rely on type coercion. One reason for that is that type coercion can, in fact, introduce many unexpected bugs into our program. However, this only happens when we don't really know what we're doing. So when we don't know about the stuff that I just showed you. Because if you know, then it's way easier to avoid these errors. So in my opinion, coercion is actually a great mechanism that is going to allow us to write a lot less code and also to write more readable code. So really make sure to take some time to understand how type coercion works and then just embrace it in your code.